In the 10th question that we have been given a cubical box of side 1 meters that contains helium gas. The pressure of the gas is given, and we have been given with an important information that during 1 second, an atom traveling with an RMS speed parallel to one of the edges of the cube makes 500 hits with a particle wall with no collision with other atoms, and the other values of R and K is given. We need to find out firstly the temperature of the gas. For finding out this, let us first draw the diagram as to what happens inside the cube. We have an atom. Let the side of the cube B is equal to L. We have an atom traveling with VRMS parallel to one of the edges of the cube. This velocity is parallel to this edge, and it makes collision with no other atoms. Now, it makes 500 hits with a particular wall. Let us find out the time taken by it to collide here and return back for the second collision. The time taken will be equal to 2L upon VRMS. Let it be 2L upon Vx in the general case. This is the velocity in the x direction. This is 2L upon Vx. Therefore, the number of collisions made with a particular wall in 1 second will be equal to 1 upon 2L upon Vx. This is number of collisions with a wall in 1 second is equal to 1 upon 2L upon Vx is equal to Vx upon 2L. This was the velocity that is perpendicular to the wall and parallel to one of the edges. Now we have been given number of collisions with the wall in 1 second to be equal to 500 and Vx to be equal to VRMS. Therefore, we can write 500 is equal to VRMS upon 2 into L. L is equal to 1 meters because the length of the side of the cube is equal to 1 meters. Therefore, we get VRMS is equal to 1000 meters per second. Now, VRMS is equal to 1000 meters per second. We can write root over 3 RT upon M is equal to 1000. Let us feed in the values. 3 into 25 by 3. Many times you can write R as 25 by 3. This eases the calculations in many questions. 3 into 25 by 3 into T upon molecular mass of helium gas, that is atomic mass is 4. So the mass of 1 mole is 4 grams, but we have to write this in kgs. Therefore, we write 4 into 10 raised to minus 3 is equal to 1000. Therefore, 25 by 4 into 10 raised to minus 3 into T comes out to be equal to 10 raised to 6. We multiply 10 raised to minus 3 here to get 10 raised to 3. That is equal to 1000. Now this goes away to give us 40 over here, and T is equal to 160 Kelvin. In all these formulas, the T is always in Kelvin. So first, the answer for the first part, that is temperature of gas, comes out to be equal to 160 Kelvin. Now for the B part, we need to find out the average kinetic energy of one molecule of a gas, that is average kinetic energy per atom. Now we know that average kinetic energy per atom can be written as half mass of one atom into VRMS whole square. Therefore, this can be written to be equal to half into mass of one atom. Mass of one atom of helium is equal to 4 AMU, and the mass of 1 mole of atoms is equal to 4 grams. Therefore, we write 4 AMU over here. 1 AMU is equal to 1.6 into 10 raised to minus 27 kgs. This multiplied by VRMS, that was equal to 1000 whole square, that is 10 raised to 6. So the answer comes out to be equal to 3.2 into 10 raised to minus 21 joules. So our answer for average kinetic energy per atom comes out to be equal to 3.2 into 10 raised to minus 21 joules. One important thing which we see from here is that equal to kinetic energy, the total translational kinetic energy of a gas is equal to half into total mass of the gas into VRMS whole square. This is equal to half into M into 3 RT upon M. That is equal to 3 by 2 into RT. this m is the total mass of the gas, this is the molecular mass of the gas. Therefore m upon m naught becomes equal to number of moles. Therefore the total translation kinetic energy of a gas comes out to be equal to 3 by 2 nRT. So we see that kinetic energy, total translational kinetic energy of gas is directly proportional to the temperature. That means if the temperature of an ideal gas is fixed, then the kinetic energy of the gas will be fixed, and vice versa. This is an important thing which you should note for other questions. So final answer for average kinetic energy per atom comes out to be 3.2 into 10 raised to minus 21 joules per atom is equal to 3.2 into 10 raised to minus 21 joules. Now for the third part, now we need to find out the total mass of helium gas in the box. Therefore we use the formula PV is equal to nRT, since we aim to find out the number of moles of helium in the box so that we can find out the total mass. Now pressure is given to be 100 newtons per meter square. The volume of the box is 1 meter cube. This is equal to N into 25 by 3, that is the value of R, into T. The temperature came out to be 160 Kelvin. In this formula also temperature is always written in Kelvin. 160, therefore from here we get the number of moles is equal to 3 upon 40. So we know the total number of moles of helium gas in the box. Therefore multiplying this by the molecular mass of helium, that is equal to 4 grams. We get the total mass of helium in the box, that is equal to 3 upon 10 grams, that is equal to 0.3 grams. So final answer for the temperature of the gas, helium gas, comes out to be 160 Kelvin. The average kinetic energy per atom comes out to be 3.2 into 10 raised to minus 21 joules, and the total mass of helium gas present in the box comes out to be equal to 0.3 grams.